First of all, I wanted to mention about the homework 10. I had written a note on problem 9.9 that savings should be deducted from cost. I was thinking of a different problem when I mentioned that, so you can just ignore that advice and solve problem 9.9 without any special hints. I don't think it's a particularly tough problem. In fact, the solution manual, I think it's only 2 or 3 lines long, so it's a pretty simple problem. Sorry for the mistake. The bigger thing on the horizon is the exam, which we're going to have in this room at 8 a.m. on Sunday. And there's 2 parts to the exam. The first part is 4 concept questions, and you'll solve those before you get problem 2. And so you can't use your page of notes during part 1 of the exam. Part 1 is just testing your knowledge and understanding. And when you're done with it, you'll bring your paper to the forward of the room, you'll take part 2, and that's when you start the problem solving. On the problem solving section, there are 3 questions. 1 of them uses Excel. The other 2 you solve on paper. So I think it's going to be in some ways similar to the last exam where, you know, if you keep moving, then you won't have any trouble at all as far as enough time. But people who don't understand the material or someone who gets focused on one problem and can't keep moving may feel a little bit of pressure. We're going to talk a little bit about cost-effective analysis today and ethical considerations. Before we do that, are there any questions related to the announcements? Yes? You should put any equations that you think you'd need on problem solving. And so I'd suggest that you look through the material we've covered since the first midterm exam and look at the in-class exercises and the homework problems and put equations. So you're responsible for providing any equation that you might need. If there is a table lookup problem, then I'd provide the tables. But you should either know or write down any formulas that you might need. Yes? That's right. The exam includes today's lecture and the homework assignment that you're turning in on Sunday, since that's covering today's lecture as well. Other questions? Okay. We're going to begin with the ethical discussion. And this is something we don't spend very much time talking about in your engineering coursework. If you look at the number of lectures you have, the focus on ethics, usually I think that they keep it to 491 in this, maybe 490 and 491. But it plays a big role in the course that we're taking now in cost analysis, because this is when engineers are called on to make a lot of decisions. You know, if you're just doing design, if you're designing a building or designing a roadway, the decision has already been made. But oftentimes engineers are called on to help make the decisions because they have a unique ability to solve quantitative problems. So the types of comparisons we've done in this class, the last several classes, comparing alternatives, for example. An engineer could be asked to help work on public policy and public planning. Public policy is where engineers and other people are trying to solve societal problems. And so some examples of societal problems are homelessness, drug use, environmental problems. Public planning is where a decision has been made to do something, and so now the engineers are trying to guide a project so that it's the most efficient as it can be, and it has elements of the environmental aspects, financial aspects, and societal. And so this is something that you'd think maybe someone with a background in humanities would be better equipped to work on, but it's really important for engineers to be ethical. And some of the elements of that is impartiality and avoiding favoritism. Can you think of an example of construct an idea of what if an engineer wasn't impartial? Now, what's a situation that you could be in doing cost analysis type of work where someone could break the rule of being impartial? Yes? Okay. So he said, what if a cost analysis engineer was getting paid by a company to buy their equipment? And that's absolutely an issue, and that's a good one. Just to give you an example from my own career, I wasn't getting paid to buy equipment, But here's what happened. I was working at an engineering design firm, and my analysis was having to do with stormwater. And so I would design the pipes that go under roads to take rain when it rains onto the road. And there was a company that manufactured plastic pipe, and they wanted to come to our company during lunchtime and give us a presentation, and they would buy the food and then give the presentation. And we said, fine, okay. And so they bought us the meal, they gave a presentation about their pipe, and it was kind of interesting, and then they left. A few weeks later, they started calling. So, are you going to choose our pipe for this certain project? Are you going to choose our pipe for this certain project? And there was a feeling that, oh, I guess I'm obligated to choose this plastic pipe because they bought lunch for us. And so it's a silly thing when your impartiality can be compromised from a feeling of obligation, whether someone pays you money, or maybe they are from the same hometown as you, or they bought you a sandwich. You have to avoid putting yourself in situations where someone is going to put pressure on you to make a decision that's based not on what's best, but that's based on favoring their interests. So we should avoid favoritism. What do you think it means to be realistic in making assumptions? Okay, now, not logical assumptions. Apply that to cost analysis. What sorts of assumptions have we had to make? Okay. So we have to consider all of the factors. What if, for example, you had an airport project? So you've been asked to analyze an airport project, and specifically, you're asked to analyze the disbenefits of an airport project. And your boss really wants this project to be approved. And so the boss is kind of winking at you. You know, there shouldn't be very many disbenefits. Would it be realistic if you said, well, the only disbenefits are that people who live far away can't get to the airport fast enough? And what are the real disbenefits of an airport? Okay, traffic congestion, noise pollution for the people who live around it. It could be if the jet fuel spills, there's a little bit of a safety risk. You know, airports can potentially be dangerous. And so be realistic in making your assumptions, and you have to be honest about the truth of a project. You can't make the project seem better than it is or seem worse than it is. If there's a certain alternative that your company doesn't want to consider, then they should just be honest about they don't want to do that alternative. They shouldn't pretend like they are considering an alternative and then just give it an unrealistic cost analysis. And this last one is being thorough in considering a wide range of circumstances. And this is a perfect day to talk about this. 99% of the time in the UAE it's sunny, right? 1% of the time it gets a little wet. And if you've ever driven on some of the roads, if there's a sag, a downward sag on a rainy day, so what happens to this point on a rainy day? Fills up with water, and then they have to send a truck to pump the water out. And so a wide range of circumstances, even if it's sunny 99% of the time, you have to think about what's going to happen that 1% of the time that it's wet. Because things don't fail on the average day. Civil engineering systems don't fail on the average day. They fail on the extreme day. You know, an airplane crashes, for example, when the pilot is tired and there's bad weather and a mechanical problem happens. There have to usually be overlapping problems for a catastrophe. And so it's important for engineers to think outside of the box, not just how is something going to happen in a routine basis, but what are the unusual circumstances that could arise, and factor that into your cost analysis. Well, sometimes you can only be so creative. You can't think of every possibility, but you should, as much as possible, think about, let's talk about cost analysis. What if you have a project in mind and you're counting on 6% interest for the project? You should do an analysis just to see what if the company has to pay 8% for the project. What would happen then? And so considering a wide range of circumstances means what would happen if you don't get the revenue you're expecting? What would happen if the costs are actually higher than your assumptions? And so consider a big range of possible costs, revenues, interest rate. Maybe something will break sooner than expected, and so the lifespan is only 18 years and not 20 years. So consider the risk of things being different from what you initially assumed, I think is the main idea there. The bottom line, economic analysis should not be misused or applied unethically because it's a tool like anything else. And people will be really impressed with your cash flow diagrams. People are going to look at the table that you make and say, wow, he calculated the present value and found the net present value and converted that to an annual series. People will be impressed with what you can do with the numbers, and so it's easy to trick people who don't know a lot about money or the time value of money, and it's really important not to misuse that ability to make predictions for selfish reasons. So here are some specific points that are raised by the text. Is it ethical to take public money, so the government's money, to build a project that only benefits a select few people? Like to put a small junkie park in the poor part of town and a gigantic, beautiful park in the rich neighborhoods in town, and they're both paid for with the government funds. Obviously not ethical. Here's an idea. Sometimes people are worried about making a big project that's going to put their children and their grandchildren in debt. And a lot of people raised the second point during bank bailouts of 2008 when there was a financial crisis. They're saying, we're going to take government money and give it to banks so the banks don't go out of business. And who ends up paying for that is the children who we didn't ask for their permission to spend the money, but they're the ones who have to pay the debt through their whole lives. So that's another thing, is we have to avoid long-term projects that are of questionable benefit, especially if it's going to have a big cost for future generations. This third point is something that unfortunately happens a lot in transportation. If there's going to be a new road, sometimes planners will decide to put the new road through the poorest neighborhoods in town because it costs the least to buy the land because it's poor neighborhoods. And then the people around it are going to have the extra noise and the extra congestion of a new road. But since they don't have much ability to raise concerns with politicians, they have less influence than people in richer neighborhoods. And so sometimes projects have a disproportional disbenefit on poor people or minority groups. Pollution of water for areas that have minorities was a point raised by the textbook, and how it's not ethical to load all of the disbenefits on people who have less advantages. The other point that was made by the textbook is when we try and put a dollar value on a disbenefit or a cost, sometimes that's not enough. And in the problem that I was talking about earlier, problem 9 on your homework, it talks about arsenic contamination of drinking water. Has anyone already done that problem? Not yet? The idea behind that homework problem is it asks you to consider the cost and the benefits of arsenic reduction in drinking water. Because if there's arsenic in water, people can get sick and get cancer and they'll die from that. But it's very expensive to remove arsenic from drinking water. And so in the question in the book, it's just saying compare the cost and compare the benefits, and is it worthwhile? But what this point is saying is you can't only consider the financial costs of things. You have to have other values besides money. And even if you can make money by polluting water, and even if the lives, the monetary value of human life is $4 million per person, and the benefits is greater than the life you're taking away, you have to have some other ethical considerations besides just making the most money you can. And finally, sometimes it's hard to quantify things, and if you're used to putting it into a spreadsheet, sometimes you would reject an option just because it's not something that you can quantify. There may be an alternative that just it's difficult to estimate what the financial value of the benefits are. And so it's not ethical to reject options just because they're hard to estimate. I'd encourage you to read through the section in the textbook that talks about ethics. It's only a couple of pages, but it raises a lot of interesting issues that we engineers don't think of very often. All right, well, let's get into some problem solving. Cost effectiveness analysis is sometimes used instead of B to C ratios, where we want to find out how efficient an office is at doing a certain thing. And so it's used in the service sector. And what we mean by service sector is that part of the economy that doesn't produce solid items. You know, like there are material goods like cars and ships and airplanes. Those are durable goods. But services are things that are considered intangible. Healthcare, accounting, the police. You know, the police being out there on the road patrolling, what they do is prevent crime. But that's not something you can hold in your hand. And so these intangibles in the service sector, they provide valuable services to our community, and there has to be a way for us to analyze how effective they are at doing it. The book makes the point that this cost-effective analysis is sometimes used instead of B to C ratio because in the B to C, what's the conventional formula for B to C? Do you remember that? B minus D, CI plus C M and O. Right, good. So benefits minus disbenefits. We can't use this formula if we don't know how to put a number on the benefits. For example, a traffic camera. The camera that takes a picture if you're speeding. No one likes to pay a speeding ticket, right? It's terrible. Raise your hand if you've ever been caught on a camera speeding. I have. No, not today. Every day? All right. So the disbenefit is that it makes people feel bad because they got in trouble. But what's the benefit of the traffic camera? Think about if they weren't there, how crazy people would drive. Already you're putting your life in your hands when you get on the highway. But think about how much more risky it would be if there was no traffic cameras. It would be very, very risky. So those traffic cameras are averting accidents, preventing deaths. It makes it, what if the police had to chase someone down every time it was speeding? It would be very time-consuming for the police, and so having the camera allows the police to focus on other things like solving crime and preventing problems. Another benefit is the fines that are collected. Of all of these, the only thing we can put a dollar value on is the fines, the amount of fines that are collected. The rest of those things, it's very hard to say the value of prevented crime. So, go ahead. Yeah, you could possibly look at, you know, how many police would be chasing cars down. It would be hard. There's an easier way. Rather than trying to put a dollar value on these things, the other way to analyze the effectiveness of a certain service is to look at the total costs to do it divided by some measure of what they're doing. And so in today's in-class exercise, we're going to do something similar to this illustration. We're going to begin with this illustration just looking at it. I'm going to tell you the procedure, and then we'll do the in-class exercise. So this isn't the exercise yet. Let's say, for instance, that there is 4 offices, A, B, C, and D, and each of them do the same thing. They just process passport applications. Office A, you can see, has a certain operations cost, and this is probably the salary of the people that are there. It has to do with the location because the rent is going to go into their operations cost. It's going to have to do with the utilities that they use. And so all of the costs of operating this office are $875 per hour. And we have, similarly, another cost for each of the other offices. So this is a measure of their cost. And column 3 is a measure of their effectiveness. The only thing we're judging is how many applications per month they're processing. And so you can see Office C has the most applications per month. Office D has the least. So what we can do as our next step is do a ratio of C to E, the cost to effectiveness. And it looks here that Office B is the most efficient, because what we want is the lowest number possible. The lowest number says it's the number of dollars per application. And so it only costs 5.1 cents for every application that is reviewed for Office B. And then the final step is something called the cumulative cost. And you'll notice that I've reordered the list. Here it was A, B, C, D. Now I have B, A, C, and D. And the way that I've reordered it is I've said, what's the cumulative cost? Because sometimes there is something called capital rationing, where you have a certain limited budget and you're trying to find out where to spend the money. You should always spend the money first on whoever's most efficient, and then take the leftover money to the next organization who's a little bit less efficient than your first choice, and so on. So Office B was the most efficient, and that's why I have them first. And so it costs $450 per hour to have Office B operating. Then Office A, this cumulative cost that we have here is the previous amount, $450, plus the $875 it costs to operate Office A. And so it's the sum of the two. And you can see the pattern continues in Office C. It's the previous amount plus the operations cost for Office C. And so by going through there, we can see that if we had only $2,500 available, we can pick which offices should be funded for the operations. And doing that will maximize the number of applications that get processed every month. Let me give you one more point of information, is that the units don't have to cancel out. Look at what are the units of C to E. In this case, C is dollars per hour, and E is applications per month. And so maybe because you're used to having the units work out in fluid mechanics or other courses, maybe you're thinking to multiply hours by how many hours are there in a month and so on. But it's not necessary, because we're going to be comparing all four options to each other. And so you can just consider C to E as being unitless. You know, here we have dollars per applications, but we don't know the time base of it, and that's fine. Capital rationing. If we have a certain limited budget, then this tells us how to spend it most effectively. Does everyone have a copy of in-class exercise 26? All right. That's what we're going to work on next. We're going to take a look at this case of a wildlife foundation is trying to protect endangered gorillas. We have $5 million available, and you should go through the steps that are listed on the page there, A through D, and eventually we're going to try and find out which ones should we give the money to, and how many poachers can we expect to be arrested each year. All right, so follow the same pattern that I just showed you on the example on screen. Yeah. Nope, you don't have to. You can just calculate, just find out which one is C and which one is the E, but you are going to have to find out the program cost. Cost per person is not C. You're going to have to calculate C for each organization. All right. We have 5 organizations, and we're trying to arrest poachers. And so the cost effectiveness ratio, we have to find the cost, and the total cost of the organization is their personnel multiplied by the cost per person. So that'll give you the cost, and the effectiveness is how many poachers they arrest every year. So let's take a look at the solution here. first thing I did is find the program cost for each one. That's what's in column D. And then the cost to effectiveness ratio, you can see, is the total program cost divided by the poachers per year. So the best one is Habitat XP, then Helping Hands is next. So the second step is to make a ranked list in terms of the C to E ratio. So the best to the worst. So that's what this ranked list is the Habitat XP is at the top because they have the best C to E ratio, and Gorilla Watch is at the bottom because they have the worst C to E ratio. So here's the program cost individually, and then this is the cumulative program cost. If I have both organizations, if I try to pay for Organization C and Organization A, then it needs $766,000. So in the problem statement it says we have $5 million. So if we only have $5 million, we can do Organization C, A, and E. But we don't have enough money to pay for EcoPlanet. Maybe we can give our leftover money to EcoPlanet to help support them a part of the way, but depending on the circumstances, maybe that's possible, maybe it's not. So the answer to the in-class exercise, the $5 million, which should you select? It should be C, A, and E. And then the number of poachers we expect to arrest should be 495. Because we're going to get 78 poachers from Habitat XP. We'll get the 85 from Helping Hands and 332 from Save the Forest. All right. So when you finish that, and let me take a look at your calculations, then that is it for today. Please remember to put your in-class exercise paper on the chair on the way out, and we've got an exam on Saturday, so I will see you Sunday. Are we having a Sunday? Yes, that's right, Sunday. Thank you. Still adjusting to the schedule.